Systems Architecture of Smart Parking, Cloud Application and Service IoT System. Lecture by Dr. William S. Chow. Chapter 1. What is Smart Parking IoT System? Smart Parking IoT System use wireless sensor network, which consists of a larger number of sensors placed in existing parking garage. The information obtained from each sensor is processed collaboratively to evaluate meaning metrics such as parking, garage availability, and check-in and check-out date and time of all vehicles. Behaviors of smart parking IoT system consist of the following 5 behaviors. The first behavior is finding and reserving a vacant parking slot. SBC access will publish the parking garage availability information to the nearby driver, as shown in Figure 1-3. Once the parking destination has been decided, the driver can either drive his vehicle there or make a reservation of the parking lot as shown in Figure 1-4. The second behavior is sensing parking starting time. SP cases will sense a vehicle's check-in date and time as shown in Figure 1-5 when it is driving into the parking garage. The third behavior is inquiring parking fee. A driver shall inquire SP cases on parking garage fees he or she need to pay as shown in Figure 1-6. The fourth behavior is paying parking fees. A driver shall use SP cases to pay his or her parking garage fee as shown in Figure 1-7. The last behavior is the fifth behavior, sensing parking end time. When a vehicle is ready to leave the parking garage, Smart Parking IoT system will sense its checking out date and time as shown in Figure 1-A. Chapter 2. What is SBC architecture? In general, a system is very complicated, so it includes many views. There are 2 different ways to model such many views. The first one called model multiplicity approach, such as UML. Separately pick a model for each view, as shown in Figure 2-5. UML multi-model approach will generally allow the inconsistencies among these multiple views. The second approach is called model singularity approach. Instead of choosing many inconsistent models, this approach will use only one integrated model, as shown in Figure 2-6. Structural Behavior Correlations (SBC) means to integrate the system structure and system behavior. SBC architecture uses 6 fundamental diagrams to describe a system. These 6 fundamental diagrams are AHD, FD, COD, CCD, SBC and IFD. So we say SBC architecture is a model singularity approach. Using the SBC architecture as one single model, then it will generate 6 views as 6 fundamental diagrams. Chapter 6. Framework diagram of SP cases. Framework diagram FD depicts the structural view of a system. In Figure 6-1, we have application layer, data layer, technology layer, which each layer consists of several components, as shown in Figure 6-1. Chapter 7. Component operation diagram of smart parking IoT system. Component operation diagram (COD) also depicts the structural view of a system. In Figure 7-1, we can see all the components of SP cases. Also, for each component, its operation and their input, output data are all shown in this component operation diagrams. Chapter 10. Interaction flow diagram of smart parking IoT system. Interaction flow diagram IFD depicts the behavior view of a system. SP cases include the following 5 individual diagram behaviors. The first behavior is finding and reserving a nearby vacant parking slot, as shown in Figure 10-1. Is the IFD of this behavior. There are totally 6 interactions in this IFD. The first one, the driver will use the UI component, try to see or to view the garage, the parking garage city map. Then you will Then the second interaction will get the driver GPS coordinate data from the driver GPS. Then the third interaction, the UI component will save the driver GPS coordinate data into the database. Also, we'll get the output data, parking garage query from the database. Then the driver can see the parking garage city map. That's the fourth interaction. The fifth interaction, then the driver will input one parking slot form. If he want to reserve one parking slot, then after that, the sixth interaction will be the parking garage city map UI component to save the one parking slot query data into the database. The second behavior is sensing parking starting time. In this IFD, there are 4 interactions. The first one is we will the server root actor will fork the PSTD process daemon. Then the second iteration is the parking starting time sensor will sense the car tag to get the license plate number input data. The third iteration, then the sensor component will output the license plate number to the parking starting time daemon component. The last iteration is the fourth iteration. Then this daemon component will input the parking starting time query into the database. The third IFD is inquiring parking fee behavior. There are totally 3 iterations in this IFD. The first one, the driver will input the license plate number into the UI component. Then the UI component will try to get the data, the parking duration query, output data from the database. Once the UI component gets the data, it will output the parking fee report data to the driver. That's the third iteration. The fourth IFD is paying parking fee behavior. There are 2 iterations in this IFD. The first one is the driver actor will input parking fee payment form into the UI component. Then the UI component will use the second iteration to input the parking fee payment query to the database. The fifth IFD is sensing parking end time behavior. In this IFD, there are totally 4 iterations. The first iteration is the server root actor to fork PETD process to the parking end time daemon component. The second iteration is the parking end time sensor will get the license plate number input data from the car tag actor. Then after that, the sensor component will output the license plate number to the daemon component. The fourth iteration is this daemon component will input the parking end time query data into the database. Here, let's do some advertisement. Actually, this book is on sale on the Amazon website. You can see the URL website address on this page. The full name of this book is called System Architecture of Smart Parking Cloud Application and Service IoT System. It is written by Dr. William S. Chow. If you want to read in more detail about this lecture, you can go get this book and read it in detail. Finally, thank you for your listening. I'm Dr. William Chow. I can be reached by the following email. You are much welcome to email me and discuss any question you want to discuss with me. Also, you can visit our SBC Architecture official website. Thank you. Bye-bye.